We are given n candidates who are interviewed in a completely random order. A candidate is hired if they are better than all the candidates interviewed up to that point. Since there is no one to compare the first candidate with, the first candidate is always hired. Assuming no two candidates are equally competent, what is the probability that you hire exactly 2 times? This is the problem we are going to solve now. The answer is this, but let me explain how. So let's say the first candidate is the best candidate. If the first candidate is the best candidate, in that case, can we hire 2 candidates? No, because if this is the best candidate, then we will be hiring exactly 1 candidate. So this is not a good case for us. Second case is, let's say the first candidate is second best. First candidate is second best. In that case, the first best candidate might be any of the others and will always be hiring exactly 2 candidates. So in that case, the probability of this case is 1 by n, because what is the probability that the first candidate is second best candidate? Second best candidate is one specific candidate out of all of these, and we want that second best candidate to arrive in the beginning. The probability of that will be 1 by n. So this is one good case for us. What are the other good cases? Let's say the first candidate is third best. If the first candidate is third best, then second best and first best can come in any order. Either the first best comes before second best, or the first best comes after second best. So all the cases can be equally divided into the cases when first best comes before second and first best comes after second. So the probability of first best coming before second is 1 by 2. That is why the probability of this case will be 1 by n multiplied by 1 by 2. 1 by n is the probability that the first candidate is the third best candidate. So what if the first candidate is fourth best candidate? If the first candidate is fourth best candidate, the probability of that happening is 1 by n. Now if the first candidate is fourth best candidate, then the other 3 bests, B1, B2, B3, can come in any order. But what we want is, we want the B1 to come before B2 and B3. So the probability of that happening will be 1 by 3. The first candidate is B1. The first candidate could be B1, B2 or B3. If the first candidate is B1, the probability of that is 1 by 3. Similarly, if the first candidate is fifth best, then the case we want, the probability of that will be 1 by n into 1 by 4. So if we add all these items for fifth best, all the cases, fifth best, sixth best, etc., we will get this answer.